morning, everyone. Wow, this is loud. Good morning, everyone. I like starting talks with a kind of audience interaction, so please raise your hand if you ever had to write front-end code as part of your career. All right, that's good. Now keep your hand up if you ever had to write a date picker or a custom select box. Yeah, that's pretty much almost everyone who raised their hand at the first one, and that's exactly the problem. In fact, if we actually search on NPM, we have over 1,200 packages for date pickers. I personally think that's too much. And for a while, we've been asking browsers to implement something like a date picker that we can just use. The same way we have video, input text, we just want to have a date picker. And this is sort of where web components actually come into play. And over the next 20 minutes, I want to talk about why I believe that 2018 is actually the year where web components are going to be interesting. And we're mostly through 2018, and I'm still convinced of this. But you might have heard this in 2013 already if you've been around for a while, or in fact in 2011 when the idea of web components came up. But I truly believe that 2018 is really when this is going to take off, and hopefully by the end of the talk you'll be as excited as I am about the technology. But let me quickly introduce myself. My name is Dominik. I work as a Developer Evangelist for a company called Twilio. We're an API company that does all sorts of things around sending and receiving SMS, phone calls, video chat, anything around communication. If you want to chat with me about that, my booth this time actually arrived, contrary to yesterday, so you can come by there and have a chat, and I have lots of t-shirts left. And as already announced, I'm not Polish, so I'm very sorry if you're trying to speak with me in Polish. I'm happy to talk in English, German, JavaScript, whatever you want, but not Polish. And ever since I've been developing for the web, we kind of had the same problem of how do we share actually UI concepts between projects and just inside, between teams. And there have been different approaches, from sort of this bootstrap approach where you blindly copy a bunch of style sheets in JavaScript and you don't really care what it does, or if you really need it, you just copy it. And then every time you want to have a new component, you go to the docs and you copy some random HTML that you're still not really sure if what parts you actually need. Like, what if I drop the header? Is that breaking everything? So as a result, for more complex components, we ended up having these JavaScript SDKs where you give it a bunch of options and you give it a DOM node, and then magically everything is being placed in there. And if you didn't like either of those approaches, some people came up with more the sort of hybrid approach, where in the case of Facebook, you actually include a JavaScript SDK, and then you have to have a very specific JavaScript HTML structure that this SDK is going to look for to replace these components. But the problem is that all of these sort of lead to a poor developer experience, because unless you're writing plain HTML and JavaScript and CSS, most of these frameworks make working with these approaches very hard. You either have to fix the templating for it, or you need to actually figure out a way to interact with the DOM, even though your framework actively discourages that. So it's never been sort of a great experience. So should probably watch out where I'm walking. So as a result, people started authoring these wrapper components. And the problem is that leads to library fragmentation, because if we look at something like MDL, which is Material Design Lite, you can think of it like Bootstrap for material design. There's one for React, one for Vue, one for Preact, which actually supports a way different feature set than the React one. There's one for Angular. There's one for pretty much every framework. And they all support different features and are on different versions, which means that you might miss security patches and a bunch of other stuff. So what if we could take a step back and we could extend actually the native HTML element? Because the benefit of all those frameworks is they all know how to deal with HTML elements. So why can't we do that? And that's where web components come into play. And most people think of web components as one spec. It's actually a series of specs that are kind of independent of each other. And the first one is custom elements. And this is really the spec where we're talking about how can we extend the HTML element, just like the same way that the input tag does, the video tag does. They all extend from the HTML element base class. And kind of create our own HTML tags. And the way this works is by actually creating a new class and extending that from the HTML element. And inside there, we can actually take care of rendering whatever content we want. And then we use the custom elements registry to define our own tag so that we can use it afterwards. And then we can use it just like any other element in JavaScript or in HTML, so either declarative or imperatively. And since we have these document.createElement calls, that means that things like React and stuff actually work with this as well, because under the hood, that's what React does, is it just calls document.createElement. The other spec is the HTML template spec. So HTML templates allow you to create a structure of HTML, include styles, and all of this is not going to be rendered, but it has one property, and that's it can be really effectively cloned. So you can actually use an HTML template tag in your HTML, and you specify styles, any markup, and it's not going to be rendered, but you can grab it out of the DOM and then really effectively clone it and put it back into your page. And this is de facto the most efficient way to actually clone a node, is to use HTML templates. And then there's Shadow DOM, and Shadow DOM solves this problem that people have been crying about for a long time, and that's style encapsulation. Because Shadow DOM allows you to hide the implementation of your component so that people don't accidentally scope it, accidentally style it, or the other way around. It can't, like the styles can't bleed out. And this is being used by things like the video element, for example, or a lot of other internal existing components by the browser. And the way we use it is there's actually a method on the HTML element that's called attach shadow, and that allows us to get a shadow root that we can then interact with just like any other node and actually append children to that, for example, the content of our template. And then that means that we can actually now put content, like in this case, we're using the date picker, but we're not actually rendering anything, like we're not showing anything else in the HTML markup. We can specify children in there, render them instead of the slot place, and really know that the styles of our component are not being affected by the styles that the user writes or the other way around. And then there's HTML imports, and because we don't have a lot of time, we're not going to talk about them, but we're also not talking about them because they have been declared dead in favor of ES modules. So what's the support like? It's actually really well supported. In fact, I took a screenshot this morning, and every browser but Edge actually has it fully implemented now, and Edge started developing on it a couple of weeks ago. So they're going to have support for that very soon as well. But if you're using HTML templates or ES modules, that already works, and we can use polyfills to actually make this support work. So why would you care? First of all, if you actually develop a UI component, this is really interesting because that allows you to actually expand your user base. Suddenly, it's like your user base isn't limited by the framework that you chose to build your components. It allows people to use it regardless of what they pick. It also allows you to use the same tools for everyone. So for example, EA chose to develop all of their UI component kit using web components, so that any team can pick their own framework, but at the same time still use the same components. That means also your marketing team can use the same button that your development teams use, for example. And if you don't fall in any of those categories, it still gives you a better development experience, because the framework authors actually have to think about how you can use and interact with native elements anyways. So web components kind of fall into that category. If we talk about examples, one of my favorite examples is A-Frame. If you haven't heard of A-Frame, it allows you to build web AR and web VR experiences using HTML elements powered by web components. So that means that we can have a demo like this one that I can't really jump in because of the time. But like having a cube in like a VR world and a text really just boils down to some HTML that crashed that screen, but not that one, so that's good. Really just boils down to some HTML. And that means that if you don't actually understand how this works, you can still go and actually use, just modify, like look at the HTML and see that there's an a text tag. And if we want to change that to hello jsPoland, all we have to do is change the value property. And this is something that you don't have to read documentation for forever, because all of us tend to know how HTML works. It's also great for things like progressive enhancements. My colleague Phil Nash actually wrote a web share wrapper component that actually allows you to do this progressive enhancement so that we can use the web share API that is still not widely supported. But if it doesn't work, we can fall back and still even have a fallback in case web components are not supported. We can fall back to the A tag. And if you followed the Chrome Developer Summit last week, there were a lot of other web components launched and announced to prove sort of different proofs of concept, like the virtual scroller, which I'm very excited about, or the 3D model viewer. So if this is also great, why didn't we get this earlier? Like, we've been talking about this since 2011. The first thing is browser support. Like, the browsers took a long time to implement this, and the reason for this is that people weren't really like implementing this and using this. So if you're not using a feature, the browsers are not going to implement this. So it's sort of a chicken and egg problem, because a lot of people are like, I'm not going to use it because I need to use polyfills. But the browsers will not implement it if we don't use it, or at least not immediately. And that's due to the fact that it's a very low-level API, similar to WebGL and everything else. Like, it is a very low-level API that requires you to add tooling to make it actually very nicely usable. And that's due to the Extensible Web Manifesto. So the Extensible Web Manifesto, if you haven't heard of it, is a thing that all the browser vendors sort of agreed on, and different standard bodies agreed on to figure out what we're actually going to standardize. And in there it says that that the standards process should really focus on adding only adding new low-level capabilities, such as WebGL or web components. And they should explain existing features. So that's what CSS Houdini does as well, for example. Because this way, we like the browser vendors and the standard bodies don't have to figure out what we want, because what we want constantly changes anyways. And if you want to learn more about that, there was a fantastic talk by Monica about how the web sausage gets made, which exactly talks about this. And I'm going to share the slides later so you can actually take a look at that. And because it's such a low-level API, we need good tooling to actually make the development experience nice. And in the past, pretty much there was Polymer that was like championing this web components approach, or you could write plain web components. But similar how like barely anyone writes WebGL and instead uses like Three.js or like A-Frame, we want to have like a nice way to consume this. So by now we have way more different options to do this. There's been Stencil and Skate.js, but also like frameworks like Vue, Angular, or Amber are actually looking into how they can take their existing components that their community wrote and actually turning them into web components. Because ultimately web components are about picking your favorite and letting others pick theirs. And I've talked a lot, and I still have 8 minutes, so I figured we're going to actually solve the problem that we all had and actually build the very last date picker. Except if you ever build a calendar, you know we can't do this in 8 minutes. So we're going to build a rating component, and in fact, we only have 8 minutes, so I already built it. And one thing you need to know is I belong to a lovely group of people that is called Onesie.js. We love going to conferences in onesies. I didn't bring mine this time because I didn't have space. But what I want to do is I want to get some feedback from all of you about how you like the talk. So we're going to build a rating component that lets you rate my talk based on pandas, because I tend to wear a panda onesie. And we're going to use lit element for this. So if you haven't heard of lit element, it's written by the Polymer team. And it's a simple base class that kind of sits on top of HTML element that uses lit HTML to render these custom elements. And that means it completely uses web standards, meaning we don't need to compile anything. I'm going to use Parcel to do the module bundling, so I don't actually have to type a full URL in to pull in the ES module. And lit HTML is powered by HTML templates, which means that it's actually going to be really efficient in re-rendering. All right. With that, let's take a look. And I'm going to switch to duplicate. All right. So what I have right now is a basic app that I started with the Angular CLI. So I'm going to kick this off. And while this is kicking off, so basically all I did, we can hide this. All I did is I added a bit of HTML here, which we're going to look at in a second. And then I added one function here that's called submit rating that will allow us later to submit this, because I didn't want you to watch me writing an HTTP request. And if we now refresh this, and the page is loading. Cool. So this is the page that that you should see in a couple of seconds, hosted here. It's already hosted, but it doesn't have this component here. So what we're going to do is we're going to add the rating here. And for the sake of time, as I said, I already wrote the component and published it to NPM. So I'm not going to write it from scratch, but I'm going to show you first how you can actually consume a web component. So Angular does this thing where it tries to verify or validate what kind of components you're having in there. So we need to actually let Angular know that we're using custom elements here. So I'm going to import this schema. So that just tells Angular, hey, it's totally fine if you find a component that you can't match with an Angular component, because that might be a custom element. And then we need to import our component. So I have it published to npm, and I installed it as a dependency here. So we have that pulled in. And now the last thing we need to do is we need to go into our HTML. And I'm going to put this in here. I'm going to use the emoji rating component, save this, and now it's there. All right. So that easy, it's that easy to use the component. But right now, if we're changing this, it's not actually updating the number here. And additionally, I don't like that the background is black, so we're going to change that as well. So this entire component is styled using the shadow DOM. And that means we can't completely change everything. But what we can do is it exposes a very specific API of things that we can theme using CSS variables. So what we can do is we can change the unselected color here, because that's the one component, that's the one property that I exposed. I'm going to change this to white, and now we have this white thing. And that's really nice, because if you're designing a component, you don't have to worry about people messing around with everything anymore. You can specify exactly what kind of API of styles you want to give people to interact with. All right, now the other thing is we want to attach to, like, we're going to change this. And what I'm doing in the component is I'm actually dispatching a change event so that we can add an event listener for the change event. The way you do that in Angular is we're going to use the this banana syntax here, and we're going to do the change. I'm going to create a function here called handle change. I'm going to save this, and I'm going to go into the app component and create this function. So we're going to create handle change, which gets an event, and then we're going to get the current value, similar to what we're used to event target.value, and then we're going to assign the current value to this value. Now the one thing is that, like, since I'm using custom events, the change detection is actually unfortunately not being triggered here, so we're going to do that manually. So we're going to pull in the change detector ref. And I'm just going to write CDR detect changes to let Angular know, hey, trigger change detection. And now we can see this actually works. It's updating these values. That's all I wanted. So what I'm going to do is I'm going to quickly deploy this because doing things live is fun. It's always good to have very useful commit messages. And straight to master. Let's see. We're relying on internet connection here. That works. Cool. So while this is deploying to Netlify, I want to show you one more thing. So let's actually look at how this is built. Because I knew the API now, but let's actually look at how it looks. So this is the entire code for the component, and we can walk through it. So what I'm doing here is I'm extending from the lit element, and I'm defining a certain set of properties. So these properties are HTML, those are JavaScript properties on the class. But what lit element is actually going to do is it's going to connect these to the attributes as well, so that if you're setting one of these values as an attribute, it will parse it and then set it as a property. And then I say some default values here. And then I have a render function. And this render function returns lit HTML. So that lit HTML is basically a template tag that wraps the entire thing. And then we have some CSS here. You can see my variable here that defined this. And then some HTML structure here. And a repeat function. So that's just going to trigger this render emoji, which again creates some HTML. And it has an @click, which is the event listener for click. And then what we're doing here is we're updating the value and then dispatching a new event for the change. And then we define this as emoji rating. So that's all we're really doing here. All right, so while this is deploying, let's wrap this up because I have 1 minute left. So to completely summarize this, I want you to think about web components whenever you're thinking about UI that you want to share. I'm not telling you to build your entire app using web components. But if you're trying to share UI with another team or with the world, think about web components. Because web components are not here to limit your framework choices. They're ultimately here so that you can pick your favorite code and don't limit others with picking theirs. If you want to learn more, webcomponents.org sort of has the entire info on like the spec and everything else. Custom Elements Everywhere is a great website if you want to figure out if your framework of choice actually has good support for web components. Angular, for example, has perfect support and doesn't have any current open issues, but it constantly runs tests against all of these frameworks and has a list of like what are the open GitHub issues so that you can track it. Web Components To Do is a great project if you want to learn about like different ways to author web components and compare the code before diving into yourself. It kind of tries to cover everything that there is. I also wrote a blog post on how you can use Stencil if you want to check that out. We didn't have enough time. My slides are up on that URL, and if you want to vote, that's the URL now. You have a couple of seconds to grab this. And with that, thank you everyone for your attention. If you have any questions, I'll be most of the time at the Twilio booth, so feel free to come by and ask me any questions. Thank you.